Oh, jeez Louise, Sally on Sundays. Hey guys and gals, how's it going? How is it going today? Appreciate you hitting that play button. Let's go! You are super awesome for doing that. You are super awesome. Let's go. This is for you parents that are homeschooling their children or child. Appreciate you finding the channel. That's awesome. Here to help. That's kind of what I'm. The goal is, the plan, the intention. Not just parents, but also any students that may be looking for, extra support online on YouTube in regards to mathematics. I am here to help. I'll do my best to give you quick and good tips, good advice, quick tips and tricks, and all those sort of things. So yeah, appreciate you being here. Let's get going. Okay. So last video we were working on definitions. Kind of had to get that part, done, right? It's kind of all part of it, guys and gals. Understanding the terminology and the definitions and such is kind of necessary. Get my words out today, maybe. Doing my best to keep a positive attitude right now. Understanding the terminology. Okay, we're good. Just had to check the stream quickly. I'm my own mod here, so I have to make sure everything's good and you guys and gals can hear me. Okay, so we are working on Unit 5 Geometry. That's what we're doing. And so I have something here we're going to work on. Okay. Referent angles is a common standard angle used to estimate angles. For example, the different ways to slice a pizza can be used as reference. Excuse me, as shown in the figure. Start by cutting a long line segment OA, which I don't really see here. Oh, here's O, the origin, OA. line segment, right? OB, OC, OD, OE, OF, and OG. Okay, so what they're essentially doing here, guys and gals, is, I mean, we're never gonna measure the interior angle of a pizza. I mean, that's not something we normally do, right? But it doesn't hurt to, work with the math and the numbers and just figure out angles and use a pizza as kind of a reference, kind of as a guideline, right? Doesn't hurt. So they're talking about angle of slice AOB. So A, O, and B. So that's this one right here. Okay. AOB. And so if we continued cutting, we would get apparently 12 slices. So this would be one slice out of 12. Okay. Basically, we would be cutting slices at that same angle. We'd have to be consistent throughout the whole pizza. Okay, so they're showing us an example here. Again, a circle is 360 degrees, right? Full circle. And so to figure out the interior angle, essentially we're just going to be dividing it by 12 or however many pieces we're going to be, slicing or cutting for. So a quicker way to kind of write it would be just take the 360. I guess I could show the work the way they're doing it, but essentially we have 360. Again, 360 is a whole number. It is over 1, and we're multiplying it by, our plan is to cut it into 12 even slices, okay? And this is it, showing the work. If we continue, we essentially end up with 360 over 12. Okay, now we can quickly reduce this. Like I said, guys and gals, I usually use the it's not, euphemism's not the right word. I had the correct word. We'll just say, as an example, I use the term pulling as much meat off the bone, right? So we're talking about factoring here. So I want to find the largest number. 12 is a good number we can start with. If we really think about it, what do we know about 36? Just ignore the 0, okay? We'll just kind of go over reducing really quick. So this is if you're showing your work without a calculator. This is how you do it. So what do you know about 36? You know that, let's see, what do we know? Now, I guess I could bring up the times table. That might help. Let's see, where is that? Give me a sec here. I'll bring up the times table. All right, here we go. Okay, we're looking for 36, right? So there we go, 36. We know 6 times 6 is 36. So we have 6 times 6. Oh, goodness gracious. Okay, and what else do we know? Anything else here that has 36? 12. Well, there we go. 12 times 3. That's kind of the nice thing about going all the way to 12. Now I actually have that number. So 12 times 3. We could have figured that out easily as well. Just by doubling this, multiplying that by 2, and then dividing this by 2. Right, would give us the same thing. If we double one of them, we would get 12. And again, math is a balancing game, right, guys and gals, right? What you have to do, what you do to one side, you have to do the opposite on the other side. That's a plus minus or multiply, divide. Okay? So as a quick example, so half of 6 is 3. And I'm just going to clean up all of that up there. So we have 12 times 3. And that's what we're looking for essentially. That's what we wanted. So we know obviously 12 is the common number. Okay, I'm also just go here because I'm kind of running out of room. So I'm going to break. Let me just go like this. This guy's kind of in my way here right now. I did want to delete him. I like him. Just going to go a little higher here. 6 times 6 and 12 times 3. Okay? So that's our number. The biggest number we want for factoring. And it goes into 12 and then obviously and it goes into 36. So, breaking into parts, we know actually this is going to have to be 12 will go into 360. How many times? Is it 30? 30 times 12? Yeah. Okay, so we have to do something with that 0, right? So the 0 is going to be attached to the 3. So what I'm doing here is I'm going like this, taking the 12, because that is the number we want. That's the most meat off the bone because we're factoring here. We want two numbers to divide by each other, which will equal to 1, right? Essentially, they're going to be canceling each other out. That's the goal. So going like that. So we're left with times 30, right? We can't forget that 0. Okay, that 0 has to go over here. Can't forget about it. And then what times 12 gives us 12? Well, that's times 1, right? So what we're left with, that's the nice thing about reducing, right? I didn't have to use the calculator at all. So we're left with 30 over 1, which obviously equals 30. So it works out to 30 degrees. Dropping the A's because we can. And that's basically how you reduce large numbers. Okay? So what I did essentially, guys and gals, is I ignored the 0 for now, right? And I just looked at the 36. Okay? The 0 is just bring it over to the end. Okay? All right, let's undo that. Whoops, I'm also keep that because we're going to need that. Okay? So, let's continue. Oh, I'm just actually I want that to switch. There we go. Is that gonna work? I hope so. Okay, so if I click that, perfect. Okay, our next one is 1/8. Essentially, all we're doing, really, guys and gals, is we're figuring out the angle based on slices. Right? So the first one we did was 12 slices of pizza. So essentially the tip of each pizza is going to be 30 degrees. If let's say we're cutting for 8 people, we have 8 people, right? It's all the same thing. Excuse me. Okay, we're doing this without a calculator, so we need to figure out. There is no 8 times something that equals 36, okay? But there is with 4. 4 is half of 8, right? So that's 9 times 4. there's no 8 times anything that equals 36. So we have to use 4. So 4, 9 times 4 gives us 36. So 4 is our common number, and it's going to be times 9. 4 is going to be our common number for 8, so 4 times 2. And of course, we have this 0 here, right? So that 0 has to go right here. We attach it to this number is because it's these ones that we want to cancel, okay? So this is equivalent to, we're just breaking the 360 apart. I'm just showing you the long work, how to do this without a calculator. And 4 is the largest factorable number. I should call it something else. The largest number we want to factor with. Okay? And we could actually still go down here as well. So we're going to have to factor once more, and that's fine. So these cancel. We're left with 90 over 2. Okay, we could reduce some more because 90 is an even number, right? Technically speaking. So we can actually go like this. This is the easiest way of thinking of it. We have 40 plus 10. Okay? 4 plus 4 is 8, plus 1 is 90, right? So we're just going to split this 10 up into 5 and 5. That's the easiest way to figure out what half is. So we put that 5 to that one. Actually, I'm going to go like this. We're going to put this 5 here and this 5 here. So essentially we're left with, the goal is to get what is half of 90. Essentially that's what we figured out. So that's 45 times 2. So 2 is our common number, right? You following? Two's our factorable number because we're factoring once more. Actually, I could have used 8, couldn't I? I could have, but that's okay. If you don't get the largest number initially, if you have to factor again, that's fine, guys. It's no big deal. Okay? 45 over 1. So these cancel. We're left with 45. Okay, 45 degrees is our answer. And I can confirm it with a calculator, and that's correct. Kind of showing you the long work and giving you a little tips and tricks. We're kind of like mental mathing here a little bit as well, right? You know you can split 10, you know you can split 40, you know you can split 45, right? We wanted to figure out what's half of 90 without a calculator. And you just think about it. What's the closest number to 9? Well, that's 8. That's why I went 40 plus 40. I know that's going to give me 80. What am I left with? I need 10, right? So I split the 10. And then I just added the 5 to the 40. Added the 5 to the 40. There you go. So essentially we have 45 times 2, right? It's the same as saying 45 plus 45, guys. Okay, there. What's our next one? Here. So I'll do another one, and you guys and gals, I'll do this 3/4. The rest you guys and gals could do. It's pretty easy. Okay. You can double check your answers, but 1/6 would be. You should practice the factoring is what you need. You should practice. So if I go 6, right? There you go. You know 6. you want to find that common number, the largest number that you could factor out. And obviously that's going to be 6 times 6, right? Just remember to bring your 0. Okay, just as I've been showing you. Next one, 4, right? Again, you could get the times table. You're free to snipping tool it, copy it, and yeah, and make use of it by all means. Okay, so we need 4, right? 4 times what gives us 36? It's right there. 9 times 4. Okay, so there's our common number. 9 times 4. And obviously 4 goes into, so we're looking for our factorable numbers are 4 times 9 and 4 times 1, right? And just bring your 0, and there you go. That quick. Okay, and so we'll do this one right here, and 1/2 is the same. I'll leave that for you guys and gals. So let's go 3/4, okay? Times 3/4. I'm doing this one because this one, you kind of have to do the straight multiplication. You have no choice. If this is a 1, right? It's no problem. Factoring, because you just need a divisor, right? Common divisor and numerator, just like I was showing you, okay? But we have 3/4, so really it doesn't work the same. So we actually have to do the straight multiplication, okay? Which, you know, is a little bit extra work. We could still factor, to be honest. We could reduce. So what goes into, right? Just ignore the 3 for now. We're going to just work with this number and this number. Okay? What times 4 gives us 36? That's 9. Okay? Just like we were talking about already. So 4 is our common number times 9, which is 90. And then we're going to have 4 times 1. But we're not quite done. So what we're going to be doing is, I'm just going to show you, I'm going to put everything on top. I'm going to go like this. I'll show you everything. We're just going to put everything together in one singular fraction, 4 times 1. Okay, that's what we have. Okay, 360 times 3. I could go like this so it's not so confusing. Okay, and that's going to equal, now we're going to ignore the 3, and we're going to still, excuse me, factor this. Okay, so we're breaking it apart into 4 times 90. So there's our factorable number right there. Times 90. Don't forget our 3. It's unchanged. He's just hanging out. Okay, and then 4. So there's our factorable number right there. Times 1. So what we have is, I'm just bringing it down here now. So these cancel. So now we're left with 90 times 3. And having the times table, 9 times 3 is what? 27. Okay? So I ignore the 0, just ignore it. Go 9 times 3 is 27. Now just bring the 0. Boom, that easy. So that's done. 9 times 3, and that's over 1. So our answer should be 270. If I did my math correctly. So that's 3/4. That's 75% of 360. Think of that, right? Essentially, what we're saying here is, give me 75%, if you think about it, of 360. Okay? Now you should know in your head, like, what's half half of 360 or 50%, right? 180, right? So it should be 180 plus 90. Oh, look at that. Because 90 is half of 180. So I already figured it out without even doing the calculation. So 360 times 3 divided by 4. 360 times 3 divided by 4. There we go, 270. Drop the A's. Okay, awesome awesome. Pretty easy. So like I'm showing you guys and gals here, as long as you have even numbers, or it doesn't have to be even, they could be odd numbers, as long as they have a factorable number that's common between the two, right? Instead of doing this 360 times 3, right? If you do that, then you're going to end up with a really big number, right? And then you still have to factor and reduce. Well, what I'm showing you guys and gals is, before you do any multiplying, do your factoring first, and then it makes the rest of your work easy at the end. As you can see, it's already reduced. We're done. We don't have to do anything else. Okay? Makes it a winner chicken dinner, all day breakfast on Sunday. Okay. That is that. And let's carry on. So what are we doing next? Okay. We have kind of this, I wonder if I actually scanned it. I didn't scan the whole thing, I just scanned part of it. Actually, I didn't. So just to go over some angles here quickly. Mathematics. And let's see. Where is that? Oh, these are my thumbnails. Here we go. Right here. Okay. So just remember, right triangle. We're just going to kind of go over this quickly. Acute triangle. Again, this is the angle we're concerned with. Essentially, this is the same thing, right? Still acute. It's just a mirror image. But I like to reference off of what I do here. I always think of angles rotating counterclockwise this way. So I would have an angle like this, right? Like this, right? And that would be an acute angle. It's kind of a sloppy drawing, but I'm trying to speed things up too. And then we have a straight line, right? Going here. What? Oh, right. Here. Okay. In geometry, a straight angle is an angle that measures exactly 180 degrees. Okay. I wish I could lock drawing horizontal lines. Okay, so right here, 180, that's a straight. Okay. And then oblique being one that goes right here in this quadrant. Okay, greater than 90, but not greater than 180. Okay, and that's pretty much most of them you really want to remember. And of course, the reflex, right? A reflex could be in this quadrant, or this quadrant. Okay, essentially that's a reflex. And that's a reflex. Okay, guys. Now going to, just trying to speed things up here. We're kind of going over the terminology a little bit, but it doesn't hurt. There are several basic terms used in geometry to describe straight paths. Of course, this would be a line segment, right? Same thing here. This would be a ray, right? A ray goes only in one direction, starts at a point. A line is a straight path that extends in two directions. Extends, well, what would be the word horizontally? What are they looking for? What are they looking for? Well, we kind of went over the definitions of lines and all that anyway, so. And then there's the ray, and then of course acute, right angle is 90 degrees. You'll see that symbol. Obtuse, right here, or it's an oblique, same thing. Straight angle, exactly 180. Reflex, which we just talked about, right? Here or here. And of course you have your protractor. It's kind of, obviously I can't really measure with a protractor. Protractor, let's see if I can find that image again. Protractor images. I guess it really doesn't matter. We're gonna have different types of protractors, but essentially they're all the same. I just want to find one here that's kind of large. Right, there we go. Okay, you'll get a compass set, you'll have one of these, right? Again, this would be the pivot point. I always put that on the intersection or wherever. And then I always usually measure going from right counterclockwise. And I guess it just depends on what kind of angle you're given, right? Maybe you're going to be given an angle like this. Sorry I'm drawing sloppy, guys. Right? Maybe you're going to give an angle like that or be given an angle like that. So in that case, you'll probably use this. This one here maybe, I don't know. Again, I usually go from 0 on the right side and then out this way. It's kind of the way I taught my kid as well, just so you guys and gals can get used to I might actually just leave that so instead of erasing it all the time. So I'm going to try to draw this. Y, positive, X, positive, okay, and what were we doing here? Right, so 0, 90, 180. As you can see, we're going this direction, right? Counterclockwise. Okay, so the other thing is this is the intersection. So this is coordinates 0, 0. It's also called the origin. These are perpendicular to each other, guys and gals. Okay. The origin is 0, 0, which is also x, y. Okay. And from here, this is negative. So we actually go like this in a negative direction. Now to bring up the... let's see, what am I looking for here? The integer grid here quickly. Right here, right? So with this, guys and gals, from 0, 0 is the origin, right? So 0 would be right where this is, this intersection, okay? All positive values go right, all negative values go left from the intersection. So you could actually put this intersection right here, okay? That would be 0. I don't need that anymore. Okay, and then down here is 270. And so this is negative x, and this is negative y. Okay? All right, let's leave that. Let's carry on. And we'll close that. Again, like I said, it just depends on the angle you're given. Will determine how you're going to measure it, right? So normally it would be from right to left, but this one's mirror image is going from left to right. So this is how you would measure it. Your intersection of your protractor would be right there, right? So, and then you just line up the ticks and get it as close as possible. It doesn't have to be perfect. Okay, bisecting an angle. To bisect an angle is divide the angle in half. The ray that bisects an angle is called a bisector. So that was that line that we would draw right here, from here. Of course, you know, I believe, I don't know if, does it have to be the exact same, does it have to be perfectly center? I don't know. Bisect the angle shown on the right. I think it is. We kind of went over that, but let's see. What is a bisector in geometry? Okay, let me just make sure. I want to make sure that we're correct here. The bisector is a line that divides a line segment or an angle into two equal parts. Okay, there we go. Two equal parts. So it's perfectly centered. Okay, the bisector line. The bisector of a segment always contains the midpoint of the segment. So if I bring up an image, here we go. It's so small. Right here. This will work. I just wanted to go over this so that we actually confirm this. This is an image from Geeks for Geeks. And there we go. Okay. So that means this angle will be exactly the same as this angle. So it's basically this whole angle divided by 2. Okay. Just wanted to confirm. Classify each angle as acute, right, obtuse, or straight. Okay, we've been through this. If you've been following the series, hopefully you have. Okay, where's that? Here we go. Right angle, 90 degrees. Okay, so right there, C. You can actually, the smartest thing to do is just do the ones that you know immediately, and then you can figure out the the ones that you're not 100% certain of. Do those at the end. Okay, so just get the ones that you know done and out of the way. So C is right. D is a straight, right? That makes sense. Straight line, straight. Okay, so now we're left with acute. Okay, if we remember, acute is an angle that is less than 90 degrees. Okay, less than 90. Less than 90. That's not less than 90. That doesn't look like it is. Ah, this one does though. So B is acute. Okay, obtuse. Obtuse is greater than 90. Greater than 90. Okay, so greater than 90. So right there, I'm going to say that's A. And then reflex, remember. So the key thing is to remember with reflex angles are always in this quadrant or this quadrant. Okay, just so you know, like this is called quadrant 1. This is called quadrant 2. Remember, it goes counterclockwise. Okay, counterclockwise. Okay. Two. You don't really need to know this, but it doesn't hurt to know about it right now. It's not really important. You don't really have to memorize it, but I go by quadrants, so you might hear me call them quadrants, okay? If you hear me say that, that's what I'm talking about. Okay, so reflex angles are always in quadrant 3 or quadrant 4. Okay, that's my point. So therefore, this one here, E, is the reflex. Okay, here we go. An angle is formed when two rays, right? A ray is like a point, and then it goes in one direction, right? When an angle is formed when two rays have a common endpoint called a vertex, basically where they intersect, right? Origin, vertex, I guess would be another. Vertex can be placed at an origin. All right. A protractor is an instrument that can be used to measure and draw angles. You literally would physically measure it on a piece of paper or something at your desk, right? An angle can be classified based on its size. An acute angle measures between 0 and 90. A right angle measures exactly 90. An obtuse angle measures between 90 and 180. Between 90 and 180 means quadrant 2. Okay. Straight measures exactly 180. I know we go over this a lot, but repetition's good. Okay, there you go. That's a straight. And a reflex, we've gone over that I think enough times, right? You got that down, right? Quadrant 3 and quadrant 4. Okay, adjacent angles are pairs of angles that share a common vertex and common side. Complementary angles are two angles with the sum of 90 degrees. Complementary, 90. Supplementary, 180. Okay, the sum of the angles of a triangle is 180. So A plus B plus C, all the interior angles add up to 180. Okay, so that's something else to remember. A full circle is 360, but when we're talking about adding the interior angles of a triangle, it's 180. Okay, remember that. Here you would measure with your protractor. Again, this would be technically one that goes into this quadrant, but it's mirror image, right? It's flipped. Okay. Essentially, it's the same thing, but it's just mirror image that's flipped. That's all. Okay, 5 angles are shown below, and again, we've kind of already been over this. So this would be obtuse, right? (90° is a right. Acute, right? Again, it's just a mirror image, so just think of this as a mirror image of this. So essentially, this is the same, right? It's just flipped. It's a mirror image on the about the y-axis. Okay, that's all it is. Okay, don't let it confuse you. It's still an acute. Okay, that's a straight. This could be a reflex, right? Quadrant 4. Right? Which would go all the way around, right? Technically speaking. So reflex. Okay. How are we doing for time? Wonder if we should kind of stop there. Pretty much should. We could talk about this briefly, and then we'll call it a day. So adjacent angles, we've already kind of been through this. If you want to go over the definitions and that again, just check out the part 1 video. This is part 2. Adjacent angles are pairs of angles that share a common vertex and common side. Again, remember, complementary is 90. 2 angles that add up to 90. Supplementary, 2 angles that add up to 180. That's what sum means. The 3 interior angles of a triangle are also supplementary. Which is true, right? Because they add up to 180. So you can have more than 2 angles. 1, 2, 3. Supplementary. That is, the sum of the angles of a triangle is 180, as shown in the figure on the right. Okay, so we have a 90°. So that's all. Looking at this quickly, this symbol right here, you see this symbol? Automatically tell your brain 90°. Okay, so from here to here, 90°. So essentially, to get this angle, which is kind of in this quadrant 1, right? That's why I like to talk about quadrants. I think it makes understanding this a lot easier, right, guys? I'm going to put that 1 somewhere else. So I'm just going to put it, I don't know, right here, I guess. Just kind of want it out of the way a little bit more. Okay, so we have a line. Okay, it's not perfect, but again, I can't exactly pull up my ruler on my screen and draw on my screen now, can I? Right? Oh, I exaggerated it. Okay, so it should be lower. So there we go. There we go. A little bit better. Not perfect, but a little bit better. Okay, 65°. That's given. So they've given us this angle here, 65°. Okay, that's this right there. Okay, to get this, essentially it's easy, guys. Simple subtraction. So this would be complementary, right? Complementary. 65 So 90 take away 65. I could do the long subtraction, I guess. Let's do it like this. 65. Subtract. Decide to go up a little bit higher. We'll just do the long work. It's just double digits, no big deal. Okay, so we have to borrow. We're subtracting. We have to borrow because 0 is less than 5. The number up top here has to be greater than the number below. So if it's not, we have to borrow. So turn this into an 8. Make this a 10. So we have 10. Subtract 5 here, which is 5. And now we have this 8, right? Now this is an 8. 8 take away 6 is 2. So this angle right here, we could call it whatever we want, theta. Theta equals 25 degrees. Okay, remember, they are complementary angles. Two angles with a sum of 90. Okay, B, right? So looking at this visually, automatically, you should know, right? Straight. So that means this is 180 degrees. Okay, so I'm gonna clean up things here. Okay, so 180 degrees, right? And they've given us an angle here of 38 degrees. Whoa, I have no idea what I did there. I pressed the middle mouse button and that just went zoom. So this would be a supplementary angle, right? Even though it's only two angles, they're still supplementary. Again, you could have two or more. This one has three angles. It's still supplementary because it adds up to 180. Right? That's key. So now we're going to be going like this. So they've given us this, which is 38 degrees. Okay, so I'm just going to write it in there. So all we have to do is figure out this here. Okay, this is the unknown. Okay? Unknown. So we know this is 180 degrees to there. So it's going to be basically 180 take away 38. Okay. I can borrow from this 8. It's fine. So I do have 17 here still. This becomes a 10. So I have 10 take away 8 here, which is 2. Now this is 17 technically speaking, okay? 7 take away 3 is 4. Just bring down the 1. Okay? So that means, so talking about this is a oblique angle, right? Or obtuse. Obtuse. Is that correct? Obtuse angle measures between 90 and 180. That's correct. Greater than 90, but less than 180. So there we go. Our unknown angle, it doesn't really matter, but I could go question mark equals 142 degrees. Okay, it's that easy, guys. Haha. So here they're trying to, get you to think a little bit. That's all they're doing, guys. So remember the bisector? So it says x here and x here, right? So that means x and x are the same value. They're exactly the same. Okay? So that makes this a bisector. This symbol here is 90 degrees, therefore the other side is 90 degrees. So essentially what we have here is so I'm going to try to draw it in. It's supposed to be perfectly center. Okay? That's not bad. X and X. So this is X. And this is X. This is 90. Right? So essentially, remember, the bisector, it's exactly in the center. So that means we have a 90-degree angle right here, right? This is still a 90-degree angle here, right? Bisected perfectly. X and X are exactly the same value. Okay, if it says X and it says X, that means they're exactly the same, right? So essentially we have 90 minus 2x would be kind of the formula. But we're not going to do it that way. We're going to essentially go 90 divided by 2. That'll give us x. Okay? And we've already done the 90 once, right? 40. Remember how I did this earlier? You're doing this without a calculator. 4 plus 4 is 8. Plus another 1 is 9, right? So I'm just splitting the 10 into 5 and 5. Take 1 5, put it there. 1 5, put it there. I'm just adding it to it. Therefore, because we have 2, we're down to 2. That's all we want is 2 numbers, right? It's divided by 2. So therefore, x is equal to 45 degrees. Okay? That's x. All right, let's do this last one. Aha. Okay? Supplementary. Okay? Supplementary. So, we could draw it, I guess. We don't really need to, but we need to figure out this. Okay? I don't really want to draw it here, but I guess I will. I don't know, I'm just going to go something like that. Okay, this is y. This is x. Just ignore all this. So they give us 85. Right? And then this one here is 35. Okay? So, remember, supplementary. The other rule is all interior angles in a triangle add up to 180 degrees. Okay? So essentially, we're going to have a plus b plus c equals 180. For subtraction, it's the same thing. We're going to have 180. So x is going to equal to 180 minus 85 minus 35. Okay? It's that easy. If I had more room, I'd show it a little bit better, but I don't have the room, so 180 minus 85 minus 35. 180 take away 85, take away 35 equals x. Okay, so x is going to equal 60 degrees. Okay. How do we figure out y? Well, just now ignore the rest of the triangle. Y is essentially this. I'm going to erase all this over here too. Wow, I'll do it after. I'm just going to try to draw that in the same parallel line. So this is x here. This is y. Essentially, we have, what's the one that's in this quadrant? What is that again? It's a mirror image, really. It's the same line, it's just mirror image. Just flip it. It's still a oblique or obtuse angle, right? So technically speaking, we have I'm gonna try to draw this, right? We have 180 degrees here, right? That's still 180 degrees. Okay, so to figure this y, sorry guys, to figure out y is going to equal to 180 subtract x. Okay, x is 60. It's just substitution. So y is equal to 120. I did the math in my head because if I wrote 60 under here, I could see it. This is 0. 8 take away 6 is 2. Drop the 1. 120. So that's our answer. X is 60. And y is 120. Boom. Drop the A's and we'll call that good for today. Remember, just kind of refresh if you need to. Like, give yourself a break. Let it kind of sink in and absorb into the old brain molecules. Have a sleep on it. Just have a good sleep. And then just refresh your... Once you get nice and rested, refresh your memory. Kind of just go over it. And, yeah. Clean things up here. I want to actually get rid of this too here, just so I have a little more room. I wanted to I want to keep this here so that I'm not drawing it all the time. Okay, so remember the intersection is 0, 0. Okay. Just want to make sure I didn't miss anything. Doing that just to give myself a little bit more room for working here. Okay? There we go. And this one here, I don't know, I'm just going to put it right here. I kind of want it right out of the way, but that's going to have to do right there. Okay? Alright guys and gals, appreciate you watching. Thank you for, I guess, sitting here watching me erase things. You didn't really need to. But parents, here to support and help you. If you're homeschooling your child or children, here to support you on that, on your decision. Imagine you have lots on your plate, so here to help. Any students that are looking for additional support online, thank you for finding the channel. Hopefully I could help you out here as well. Kind of working on the grade 9, 10, 11 stuff, grade 9, 10, class 9, 10, whatever you want to call it. Appreciate y'all. We're working Unit 5 Geometry. I will see you guys and gals in the next video. Take care for now. Hopefully that helped. And yeah, we'll see you guys in the next video. Take care.